Hey guys, welcome back to AlgoYogi. We are now doing graph series, and our next problem in the list is find champion 2, champion 1. I don't know. Maybe we'll encounter that problem later, but for now let's solve find champion 2. There are n teams numbered from 0 to n minus 1 in a tournament. Each team is also a node in DAG. What is a DAG? DAG is directed acyclic graph. If you have already studied the graph theory, you would know this, but it's not like too complicated concept. We'll look at it this. So you are given the integer n and a 0 indexed 2D integer array edges of length m representing the DAG, where edges basically at ith position there will be u and v, where there is an edge going from u to v. So basically there is an outgoing edge from u to v, because this is a directed graph. All right, that indicates is a directed edge from team ui to vi. Same thing as I said. A directed edge from a to b in the graph means that team a is stronger than team v. So if there is an edge from a to b, A is a stronger team than B. Now, and B is a weaker team than A. So, vice versa. Team A will be the champion of the tournament if there is no team B that is stronger than Team A. Okay. Return the team that will be the champion of the tournament if there is a unique champion. Otherwise, return -1. So here they have just given the condition where this is a DAG, directed acyclic graph, so there is no cycle in this one, and basically they're saying some directed graph can have cycle. This is what they've tried to say here, but that's not very relatable to our problem. Let's go on to the example one. I'm gonna switch the viewers so that we can understand that right here. So first example, we are given the number n. N means 3 nodes that we have from 0 to n minus 1. So I have just drawn here first node 0, 1, 2. These are our edges. So basically they have given us this array edges. I have not written it here, but we can just directly write right here. So this will be given as 0, 1, then 1, 2, and that's it. There are 2 edges. So basically there is an outgoing edge from 0 to 1, so that means 0 is a stronger team than 1, because there is a outgoing edge from 1 to 2. That means 1 is a stronger team than A. So if you see in this particular example, 0 is the strongest team. That is why we will return 0 as answer. But what if we had another basically node? So let's say we had 4 nodes. I'm just changing the example here. We had 4 nodes and there was one more node here, let's say 3, that was pointing to 2. So that means 3 is a stronger team than 2. Now let's write another edge into our example, like the edges here, edges list. So that means 3 has an outgoing edge to 2. So now this is our proper edges array. So is 0 is still the strongest team in this whole tournament or this group of teams? No, there is another team 3 that also has basically no team that is stronger than itself, because 3 is greater than 2, 0 is greater than 1, 1 is greater than 2. Now 0 and 3, these are both 0 and 3. In a way, there is no way of comparing these two because they don't have any outgoing edges, right? But we could, we do not have a way of comparing, although we can say that 1 is stronger than 2, 1 is stronger than 2, 3 is stronger than 2, and 0 is stronger than 1, but we do not have any relation between these two. Okay, so that is why we cannot say, we cannot decide. So in this case we will be returning -1. Now, how do we actually find our answer? How do we go about finding our answer? So I would say there is a concept in graph that is basically about the degree. It's called in degree, out degree. What is in degree, out degree? So in degree is incoming number of edges to a particular vertex. So how about we create an array called in degree, so that will be of length in this case 4, so 0, 1, 2, 3. So let's say right here initially we can just assign 0 here, and then we're gonna go over our edges and then we will fill this up depending on at a particular vertex how many incoming edges it has. Now, why am I doing that? The reason I'm doing that is, if you see right here, the champion team is not going to have any incoming edges. Any incoming edges means it's a weaker team than where the edge is basically coming from. So let's say right now this 2 and 0, and I'm gonna change this. Let's not change this. Let's just do this one. But let's say in this particular example, we're gonna return -1, and we will also go back to our original example. But how do we find out these integers? We're gonna visit the edges, and at the edge, I will be basically, since I'm visiting, let's say, first edge, that means this 1 is receiving an edge. So at 1, I will increment this incoming by 1. How about the second edge? Second edge is 1 to 2. That means at 2, I was receiving some incoming edge from 1. So I don't care about 1 here, but I just care about because 2 is receiving an edge from some u. Okay, so I will also increment that as 1. Then 3, here 2 is again receiving one more edge, so I will increment this to 2. Now we have two nodes that have basically 2 zeros, but if we had 1, we will return that as an answer, and in this case we will be returning -1. But let's go back to our original example. We're gonna remove this thing, and then we're gonna remove this extra edge we added. That's it. We are back to our original example, which has 3 nodes. All right, how about this one? Now we're gonna do is again, 2 has one incoming edge, 1 has one incoming edge, 0 has no incoming edge. So that is why I will basically go over this in degree array that I just created, and then I will return in degree. Basically I will be returning this I, or basically this index that has in degree I equals to 0. If there are multiple of these, then I will return -1, as I said in the previous example. So I think that is pretty clear. We will be using this in degree, out degree concept, or if you want, for the very first time for this problem, I came up with the basically the approach of making a graph. In the graph, like just again have this each u and v combination, basically next to each v store how many edges it has received from something. Same concept, but this requires less memory, so I think, but both of them uses time complexity of v plus e, basically vertex plus edges. So let us write our solution. I'm going to switch the view here. Okay, so as I said, I'm going to create an in degree array which will be of length n. All right, now what I want to do is I'm going to go over u and v in my edges. So there is a edge from u to v. I don't care about where it's coming from. I know it's coming from you, but like I only care about that V is receiving one edge, so I want to increment its degree. How do I increment? V plus equals 1 plus equals 1. Initially it was 0. Now what I want to do is find my champions. So I will basically create a list. There might be multiple champions. champions. Champions, there could be multiple of them, and I'm gonna find it from Indegree. So for I in range n, there will be one champion from all these teams, which there are n teams. If my Indegree has that particular I, that index has how many Indegrees? 0. And because there might be more champions, what do I want to return? I want to return I think I wrote the wrong champions spelling. So what do I want to return? I want to return basically champion. If I just want one champion, so it has to be this. It has to exist. So there will be one champion. Then I'm going to return this guy. If the length of this champion is equals to 1, else what do I return? -1. Boom. Simple. As simple as that. Let's zoom out, and I'm gonna run it on examples. Voila. Awesome. Okay. Let's see if it gets accepted. Yes, it does. Let's write down the time complexity. So for time complexity, you can just see that we were visiting all the edges and all the nodes to create this Indegree. So we can say just we were at max. The time complexity that we are using here is v plus n. In graph theory it is mostly like v plus n, but like in general scenario it could be just max of v and n, or could be n. I don't know, but because it's like the edges can be a lot. There could be a lot of edges like going here and there, like because it's a directed graph. Okay, so it will be v plus n, or b plus e, vertex and edges, and space complexity also. Space complexity, I wouldn't say also, because Indegree is what n is the number of vertex. So I think that's what we were doing, and even the champions could be storing this all of them as champion, because there could be all separated nodes, no edges, just that's what we store. So what do? We're gonna have space complexity of big of v, number of vertex. Alright, so let's go back to AlgoYogi, mark this problem solved. See you guys later in the next problem. Until then, bye bye.